to the Advanced Unity in C# workshop. This workshop is meant to be like a list of cool stuff that it might be useful to you. You may or may not know it already. If you know it already, that's great. If you don't, you know what? It's gonna be great. And this is kind of meant for people who have tried to make something in Unity before, and have like used Unity C# scripting before. So yeah, it's gonna be focused on making your life as a programmer easier. You can totally get the same result in other ways, but they may be more, and in some cases, much more painful to do. We may not get through everything, but the slides will be there. So we're gonna go pretty fast, not super fast, but we're gonna go medium speed. So generics. Generics allow types to be parameterized. That is, the type of a method or a class can be specified during calling or instantiation. Using generics can help us create easily compatible and flexible data handling classes without needing to make a bunch of versions for each different type, each different class that you have. So if you want to reuse your code, use generics. Um, so an example, right? This is from Microsoft C# documentation. The T up here, they're kind of like template classes from other programming languages. Indicates that this class is generic up here. And so whenever a generic list object is instantiated up here, so you have this class generic list template, and you have this void add function, right? T input, and it does a thing, right? But the T can be whatever you want. So in this line over here in main, they're making a generic list filled with integers, and they are making a new generic list that's a constructor, and then they're adding a number into it. But because they use generics, they can use the same thing but with a string. And the same thing with your own custom class. So this example class is like, I don't know, you could have a generic list of enemies, right? Generic list enemy, and then a list of enemies. But you're reusing, the point is you don't have to make a new add function for every single data type that you want to make a list of. You can just have a generic list. So in short, um, use generics when you want to use a standard data structure like arrays, lists, or dictionaries. Don't make them yourself. When you want a user to decide what type a class uses for themselves. When you want to use one class for handling multiple kinds of data, or when you want to reuse a collection class very often. And don't use them when you need to use something only once, or it's specialized, or the class relies on the functionality from one data type. So if you don't even need like function like this add thing, if you don't need it to work with multiple data types, there's no point using generics. So yeah. So next, I'm going to talk about singletons, which is kind of controversial, but I think in the context of what you're doing in Unity and C# a lot, it might help you. And it's also going to use some knowledge from generics as well. So what is a singleton? A singleton is a class that only allows for a single instance of itself to be created and gives access to that created instance. It contains static variables that can accommodate unique and private instances of itself. So basically, it's a class that only has one instance of itself in your game or your project. So what are the benefits? These things can save you possibly a lot of time. So in projects where time is of the essence, you have like 24 hours or 48 hours or 3 days to make a project, right? Being efficient with your time can make a huge difference. And since there's only one instance of that class, many implementations can allow for easy access to that instance. So if you're annoyed with messy references everywhere, singletons might be your solution. Here's an example of a like base singleton class up here. So like I'm gonna, this is a script that I'm going to use in other places. So I'm going to go through to kind of explain this. Um, you'll see that this class actually uses generics right there. That's generic. Um, and it has a public static instance of itself. And a Boolean, whether it should be destroyed on load. I wouldn't worry too much about that. The main thing is this instance up here. And in the awake function, if the instance doesn't exist yet, so if there's no instance yet, the instance is this version of the component. If there is an instance already, destroy this instance. So what that ends up looking like in practice is something like this. So this is a project I did kind of recently, and we had this global audio manager that we um, treated as a singleton. For context, you don't need to have like a master class that you're inheriting from like this, like here. You can just have this stuff, this static instance and this awake function. You can just put it in your script if you want, but just for cleanliness, we did that. So this audio manager up here, and what that let us do is in a completely different class, we could just say audio manager dot instance because there's a static instance of the audio manager, right? The only one in the game. And then we can say run a function like play sound effect, and then whatever we have after that. Um, and yeah, our game manager, which was like our global kind of game control kind of thing that a bunch of scripts wanted to reference, right? We use the same thing. And alternatively, we could say like, uh, instead of creating a reference to the auto manager every time I need to use it, right? So let's just say, well, let me think of another way to do this, right? Let's just say I'm in the player movement script and I want to play a sound effect for player footsteps, right? Without singletons, what's one thing that comes to the top of my head that I might do? Maybe I find the audio manager and then I like use that um there every single time. Either I call find every single time or I store a reference to the audio manager and every single other manager that I would ever need to reference, which um yeah, find is not very efficient in what it does. So I would try to avoid it if you can, and this is just a cleaner way of doing that. Um, where you can just reference a singleton as long as it uh, is appropriate to make a singleton. Um, you can just call the only instance of that thing, like the audio manager. Even more epic, your code will be probably more cleaner, more efficient that way. Because you won't be calling find or storing references to stuff everywhere. Um, But why or when would you not use this, right? Because this sounds super convenient. This has been super convenient for me as well in a bunch of projects. It's like, um, you got a game jam or you got a game assignment, and it's like, or you're making an even bigger game, and you're like, okay, I'm going to be referencing this thing a lot, and there's only one of them, so let's make it a singleton. But when would you not make it a singleton? Well, when you need to have more than one of something, right? I mean, it's called a singleton, right? If you have like a multiplayer game and you have like 10 players, you wouldn't make your player a singleton because you know more than one. There's no like one instance of it. You can't get the benefits of using a singleton. Um, if you don't want to break the single responsibility principle, which is this fancy smancy computer science principle, but in essence, it's that classes should have only one responsibility and one reason to change. And the class making an instance of itself, the class making itself is like not something that is falls within those guidelines. So if you want to stick to the single responsibility principle, don't use singletons. Um, if something just doesn't need to be a singleton or doesn't need the benefits, like if I have this audio manager, but our game has no audio, or like we're never gonna reference it, or like we only have one sound effect in the entire game, and we're only playing once. You don't need to have a singleton for that. Um, there's also controversy about the usage of singletons, so I'm not gonna go too long about them, but I'd recommend checking them out. You'll see that thing at the bottom, singleton pattern, the root of all evil. There's some controversy about it, but yeah. Delegates. So delegates are a type that represent references to methods with a particular parameter list and return type. So it's a type that represents functions, if that makes sense, or methods in your script. So using delegates, you can use a method as an argument for other methods. Um, this includes anonymous methods and lambda expressions, which are methods that are defining code as a block without any name at all. So to explain what I mean, right? At this top line, we're declaring a delegate called del up here, and the function signature is that it has string message up here, right? So you could have a different method, right? Um, you could have a method over here like delegate method. This is an example, right? So it's called delegate method, but this could be like um int thing, right? Uh, and also takes in a string message, and you can instantiate that delegate over here. So we're making a delegate, we're making an object type del handler. We're going to call it handler, and it is the same as the delegate method up here. And now when we call the delegate like this, and we have the string argument up here, it's going to print out hello world using this function. So, oh, what the heck? Okay, there we go. Yeah, you know how I just said that the function signature has to match the delegate signature like this and this? That's not entirely true. There's a thing called variance, which lets us use methods with more or even less derived return types with delegates. So here's an example of covariance right here. So if you have up here mammals and then dogs inherits for mammals, in the program, we define the delegate mammals handler method up here. It returns mammals up here. So this function mammals handler returns mammals, returns null. Public static dogs returns dogs. It's called dogs handler returns null. And in this test function here, the handler method, so this delegate, we're defining a new delegate handler called handler mammals, and we're setting it equal to mammals handler right here. So we're setting this delegate here equal to the function that's right here. And covariance means that we can use the same method, the same handler method here, and which returns mammals. We're making a new one called handler dogs, and we're adding this function instead. Even though this one's dogs and this one's mammals, because dogs inherits from mammals, it works. You can also multicast delegates. So this is something that might be useful for you, more useful than the stuff on the previous slides. You can combine delegates using just the addition operator called multicasting. And invoking a multicast delegate invokes all the functions that you put into it, all the methods that you put in. And you can remove them with the minus operator. So what does that look like, right? We got static void hello up here. It says hello. We have static void goodbye. It goes goodbye. Grants it out to the console. And we have a bunch of delegates up here, right? So hi del, which is this one delegate over here, we're going to set that equal to this function, hello. We have this bye delegate, right? We're going to set that equal to goodbye. And then these two delegate multi-del, we're going to set that equal to hi del plus bye del, which means it's going to run both, right? And if we want to remove it, we can just remove it. So multi minus hi del. I don't like this. This is an example from like some Unity, Microsoft C# thing. I kind of don't like this variable name, but whatever. Multi minus hi del is just this one, but you just remove hi del. And so when you call it, it does this result. So when you do hi del, it says hi. When you say goodbye, it says goodbye. When you run the multiple where these are combined, it does both. And when you do the one where you remove the hi, it just says goodbye. So basically, imagine adding functions together, and then you can run multiple functions at the same time. So if you had something like, I'm imagining something like a turn-based RPG or something, and you have like each function that gets added is like a status effect. Imagine like burn or electricity, right? And all that. And then when the actual action happens, right, you could say like you run the this turn's action and it does all the status effects that you added to it, stuff like that. So some generic delegates, action and func. So action and func are both used, they're both generic subclasses of the delegate and can be used whenever a delegate is used. Action delegates can hold methods that return void. As long as they return void, you can use it. Function delegates return methods that have a specified return type. And they can hold methods up to 16 different arguments. If you go to 17, you just can't use those. If you want more info, it'll be in the slides, but they're a cool thing. I personally don't have a ton of experience with them because of something that will be on a future slide that I use instead, but they're very interesting and you should go look into them. So this is, if you've not heard of delegates, but you've heard of structs, this might be something more in tune with you. I don't know which CS class here like starts teaching like C or like anything with structs, but if you take another CS course, you might know what a struct is. You can use these in Unity and C# too. Use your knowledge from other CS courses in game dev, because a lot of people just don't. They go over to Unity and C# from their CS classes, and they're like, okay, I'm gonna learn this new thing, and they don't use any of the old stuff. So here you go. Here's a struct. So what is this? We used this recently in that Singleton audio manager that I was talking about previously, right? So the audio manager has this custom struct in it called sound effect, and it has a public string name, and it has a list of audio clips that are associated with that name. And then it has a list of sound effects right there. And so the idea is in the inspector, where's my list, right? My list is public, right? I should be able to see a list of stuff right here, but I don't see it. Well, over here, I didn't mark this struct as a serializable data type, right? So it's not serializable. You can't see it in the inspector, right? But once I do, up here, you put this tag serializable right above it. Bam, it's in the inspector. I have a list. I can now, or more importantly, anyone who's a programmer can look at this and say, oh, I hit the funny plus button down here in the bottom right, and I can add these sound effects where I put the name of the sound effect and I put the clips that are associated with it. Bam, whenever I need to call that sound effect, it just finds the name and it picks a random clip from those and it runs it. So there's a ton of other instances where custom structs could be useful, but this is one I used recently, so I figured why not put it in. Might be useful for you too in your games. Coroutines. Some of you may know what coroutines are already, and that's great. I can't imagine working without coroutines. So in Unity, all called methods need to complete before the next frame is displayed, like to your screen, right? So, if you get an infinite loop, your game will freeze. It'll freak the hell out. But what's coroutine? Coroutines are methods that stop themselves and let the frame complete. So it lets you take yourself out of that being trapped within each frame, and it lets you do things over time, just outside of the concept of frames. So this lets us create over time or suspended methods that stop and start execution in real time. So to call a coroutine, you have to use the start coroutine method. A delegate D, where D is a delegate which returns IEnumerator. So here's an example from Unity, right? Here's a function called fade, and it goes, how do I put this? This kind of function here will go entirely in one frame because it's a void function here, right? It's just gonna, the idea behind this function is it's a float ft equals 1, as long as ft is greater than or equal to 0, do the thing, and reduce it by 0.1 every frame, or every time this thing is run, not every frame, sorry. And then it changes the color of the renderer to the alpha of that renderer to that color that's going down. So it will fade this object from being full to fully transparent. But because it's a void function, it's all going to happen in one frame. So it'll go from inst to full transparency to no transparency. Sorry, like it'll fade out within one frame. You're not going to see it go gradually once, like at a time, if you know what I mean. But in the coroutine right here, right? It's the same thing, except we yield return null down here. And that means we just end the frame right here. So to see that, we'll go over here, right? Here's an example of a coroutine. And you can do funny things like wait for seconds. If you've had things in your code where it's like, how do I just wait 5 seconds in my code, right? Like, can I do that? Well, you can with a coroutine right here. So another side project here. We have this end sequence coroutine that gets run at the end of the game, and it plays a funny sound effect. It waits 5 seconds. It starts a 3-second crossfade, and then it waits 3 seconds for that crossfade to end, right? And then it closes the app. So as you can see right here, the player goes around the corner, they see a thing, and then it waits 5 seconds. Once the 5 seconds are up, this crossfade starts, so it starts dimming, and after 3 seconds, quits the game. So yield return and yield instruction objects. So yield return statements can tell coroutines where they should stop and when. Yield return can return a yield instruction or a custom yield instruction. So the coroutine is going to continue until the returned objects keep waiting property is false. And yield returning null will just tell the coroutine to keep going after the next frame, to keep going the next frame. So if we go over here, yield return null, in this top function, all this has to happen in one frame. But in this, it just says, okay, let the frame keep going. So this thing keeps going after 10, 1 divided by 10, after 10 frames, it'll be faded out. So some nice things for you. Wait for seconds, float seconds. So you can just tell it to wait some amount of time of in-game time. Like, I think I used it back here. Wait 5 seconds. Wait for seconds real time. You can wait in unscaled time. So some games will, like in Unity, you can change the time scale of the game. Like you can make time move twice as fast, right? But if you have a menu, you don't want that to be a factor that's affected. Then you can use wait for seconds real time over here. Wait until delegate D. It will wait until the delegate returns true. And wait while will do the opposite. It will wait until the delegate returns false. So you can wait until other functions finish playing. So you could like wait until and then another function basically right there. Or you can make some other thing. You make your own coroutine trigger objects. And if you want that, they'll be on the slides. If you need something similar that's not coroutines, the Unity mono behavior, the thing that Unity gives you to inherit from, has a nice method for you made called invoke. I personally don't like it, but I thought I'd mention it. So you call invoke, and then it's going to be weird. It's the string of the name of the function, and then the float for the amount of time. So in this example here, we have this function called the launch projectile, where it creates a projectile and it launches it. So in the start function, I invoke it after 2 seconds. So the argument is just the name of the function, and it does it after 2 seconds. It's not nearly as customizable as a coroutine because you can't like add times within the function, right? But if you need something like that real quick, that's there too. So Unity events. Actually, I'm gonna move this over to the side real quick. Give me 1 second. Bam. Okay. Thank you, Jonah, for answering things in chat. What I moved is I moved my Discord over, and I'm like, wait a minute, I forgot because I didn't see any questions, and I'm like, wait a minute, the Discord has their chat channels now per voice chat, so, and I'm like, okay, shit, I should probably put that there, but here it is. There's wait until D, call D. Yeah, it should call D and then wait until it returns true. I believe. I believe Jonah's right. Yeah, I believe it does. Unity events. So Unity event objects hold listeners. They're kind of like delegates. Each listener has a method associated with it. When the Unity event is invoked, so you'll see here there's a my.invoke. Every listener calls the methods associated with them. So they're kind of like multicast delegates, except they're built into Unity, so they're Unity specific, and they only allow action delegates with no arguments. However, they're somewhat more stable, so you don't have to worry about your Unity event just losing its listeners. So how does that look like? Here's something I used in a previous project, right? It's pretty simple. You'll see a public Unity event enter event and a public Unity event exit event right here, right? And if you've used Unity before, you might recognize on trigger enter and on trigger exit. So when something matching the tag check string right here enters this trigger, it invokes the enter event. And I have a set number of uses. That way we can make things only work like once or twice or infinite times. And the same thing happens when you exit. So what does that look like here? Now, this might be useful for, no, I can imagine Unity events being very useful for a lot of you. So if you look in the inspector, you can see my public enter event over here. These two, my enter event and my exit event right here. And what you can do in Unity, in the inspector, is you can hit the plus button here, and you can drag in a different game object. So I dragged in the game manager here, and then I selected from the game manager script any function I want. So in this scenario, we had an invisible trigger here. So the box collider has a trigger on it, or well, it's set to trigger, right? So it will run on trigger enter when, uh, in this case, the tag check is the player. The player walks through it, right? It's gonna run the script, no, not the script, the function in the game manager called activate segment, and I you can set the argument that you want to put in there. So I set the argument to 1. So when I walk into this trigger, it'll activate segment 1. And why is that useful, right? Why couldn't I just make a script that says like on trigger enter activate segment 1? Well, the answer is it's super easy for me to use this for any other this one script for anything where I need to detect the player walking into something. So I could keep adding more. The plus is still here even after this thing is here. I could add more functions. I could use um something like, oh, I wanted to activate segment 1, and then I want it to turn the player's camera off, and I want to disable their movement. You can add all that into this event. Just keep adding more and more things, and do it like that, and make it much cleaner. So yeah, this trigger script is just used everywhere in the game, whenever we need invisible triggers for anything. So yeah, if you want more on that, there's going to be some links in the slides. And this I think this might be close to the last bit. Um, interfaces and inheritance. So what the heck is an interface? An interface is a set of methods, properties, and other members that a target class must implement. So they're kind of like classes, but much simpler. So if you look here, there's a like this public interface damageable, right? It has a int current health that you can get, and a void function apply damage int damage. So this can be super useful in like a ton of games, right? Does your game have a damage system or a health system or anything like that, like enemies, right? This might be super useful for you. Um, so the main differences between classes and interfaces are that interfaces can't declare variable fields or constructors, right? Um, they also can't, they don't have like access modifiers like public, private. You'll notice that there's no like public int or private int here. Everything's public in an interface. Um, and they can't declare methods or properties implementations, only their declarations right here. So you can't put the actual like thing of what apply damage does. You can only just say, okay, all damageables need health as a variable, and they need to have a function that applies damage to them. So if you see right here, um, I have a class called enemy that implements the damageable interface right here. So it has this current health uh, int right here that it must have, and it has an apply damage function that it must have. So this enemy specific current apply damage method right here, where it says like, oh, current health minus equals the argument damage. If damage is less than 0, run the die function, private void die, something like that. But right, what if I don't have a die function, right? Luckily, that's not an interface over here. Die is only for enemies. Only enemies can die. So I can use this damageable interface for the prop class, for like destructible props in the world, right? Um, and since the props just break instantly, right? Um, you just have this is broken boolean that if the current health is 1, uh, then it's not broken. If it's 0, then it is broken. And no, it's the other way around. If it is broken, set it to 0. If not, set it to 1. And when this apply damage function gets called, it runs this break function, which breaks the prop. And why is this useful, right? You have this projectile class. So this is like your bullet, right? Some generic class right here. and it has this int damage, and whenever it hits a thing, it the argument is an I damageable, not a prop, not an enemy, but an I damageable. And what that means is that anything damageable, it just runs the apply damage function. So if you shoot and the projectile hits a prop, it'll break the prop. But if you shoot an enemy, it'll like reduce its health. Or if it's hit 0, it'll kill it. But yeah, one universal beautiful damage system. Yeah, this is treating props as if they have a health of 1. Yeah, okay, yeah. Yep, I just saw that in chat. Yep, but yes, this is super useful if you don't want to. I can imagine like other ways of doing this where it's like you hard code everything where it's like, oh, when the prop hits something, check is the thing you hit a prop? If it's a prop, do this function. If it's a enemy, do this function. If you hit another player, do this function. No, don't do that. Well, I mean you can, but like this is more efficient and clean and not painful to work with. So please do that. Um, so inheritance, I'm guessing more of you might be familiar with inheritance and interfaces because that's how it was for me, but maybe that's not the case. But uh, you might know it already. If you don't know what it is, that's totally fine. It's pretty similar to interfaces. So you'll see I have this abstract class here, interactable, right? And it has these functions in them. Okay, this maybe not be the best example, but you know what? It's there. Um, it has this public void start function. It has an update function, and it has an interact action function, right? And you can see that this grabbable class inherits from interactable. So what does it look like? Right? The base is this the same? That's the same image. Okay, yeah. This is the base interactable class. It's abstract. This isn't necessary, but in this case, I did use it. And what that means is that the class isn't meant to be used on its own. So it means that I can't just make something interactable. It's used to inherit from. So it's used to make other things interactable, not by itself. Um, it's functions that are virtual. So this is important too. It means that you can overwrite these functions later. And it has a name that makes sense, right? Like I didn't call it like, you know, Bob script number 2 or something. I don't know. You can kind of understand from just this header alone that, oh, this grabbable thing, it's some interactable object, right? Um, so here are 2 scripts, right? They both inherit from interactable, and these subclasses both have very different functions, but they override the functions from the interactable class back here, these empty ones, right? So public override void start, right? I'm overriding the start function, and I can call the base function start function. So imagine in the start function here, if I had like it say like the name of the object, right? I could make it say the name of the object, the old behavior of the interactable, and then do some new behavior as well. Um, and I have this interact action right here. Um, and it will run the base interact action, which doesn't do anything in this script because this game didn't need it. Again, not the best example, but you could have actual contents in here, unlike an interface where um, you can't have this apply damage function actually do anything. Meanwhile, in a inheritance situation, you can make the interact action actually do something in addition to whatever custom stuff you want over here. Um, so this one on the left is a grabbable. When interact action is called, it runs is being grabbed and it sets the current grabbable of the player to that. You'll see a bunch of things from the previous slides being used here. You'll see this is a singleton, the player controller dot instance. I'm using singletons there. And it sets the current grabbable to this grabbable. And if you look at the right, you'll see something called the button control, right? And you'll see Unity events right there, right? Again, useful. When you use the interact action of the button, um, it runs the base action, the base contents right here, which there's not much there, but it puts the button on cooldown, and then it runs the event right there, right? And why is that useful, right? Um, this is a basic interaction system right here where um, whenever you hit the interact key, like I don't know, E or whatever, or X or whatever people use to interact, right? Um, it raycasts from the camera to the way the camera is facing, and it hits certain layers, and then if you hit an interactable, then run the interact action, right? So if I raycast and I hit a grabbable, I'll grab the thing. If I hit a button, it'll do whatever the Unity event thing is in the button. Like it'll do like activate segment if that was the event that I was using. Um, right? So another way you could have done it is, you could have done something like this. I know the screenshot's kind of small. Maybe I should have made that bigger, but um, you'll see it starts the same. We raycast, and then we check if the thing we hit, if it's a grabbable, run the grab function. If it's a button, do the button function. If it's a pushable, do the push. You can see how this could get very long depending on what your game is, right? So doing it like this, it's just one thing, one clean thing, nice and clean. No fuss necessary. Yeah, so that's the end of what I have for you. But here's some extra tips. Uh, I swear to God, don't name your script some generic ass name like script one or moving or RMB. I don't know what an RMB is. Is that right mouse button? Is that like, I don't know. Who knows what that is? If I see another person doing that, like script, okay, really, don't name your script script1.cs, please. That's the main thing. Another developer should be able to understand the basics of what a script is for without even seeing the code, just by the name. Um, maybe not like the in-depth like functions of it, but like, yeah, it's script two. Yeah, maybe name them script two. Maybe that's better. Um, some Unity types have custom preset values built in that you can and should use. So, for example, you can use things like vector3.up, vector3.0, right? These are function things built in. Like, um, in some cases, imagine you want to check if something has stopped moving. So you're like, oh, if the velocity of, oh, I'll answer your question after. Give me a second. Uh, you want to compare like the velocity of your object, see if it's zero, right? Instead of comparing it to zero, zero, a new vector, 0, 0, 0, Unity has all these nice built-in things for you. Like if you want to make something red, the color.red is already there for you, right? Color.magenta, quaternity.identity, it's all built in. Thank you. That's all I got.